In this video, I'll be trying to walk you through all the operators in C++. Not all of them are going to be used in your day-to-day activities and program developments. However, I try to make this video to be a good reference for you to come back to whenever you're dealing with anything in the operators. Anything from as simple as an assignment operator and all the way up to the function operators. So to begin with, you're going to need to have a development environment up and running. In this video, I'm actually using Xcode, the Mac OS Xcode. And I just opened up a new project, and as you can see, these basic um, entries are already done by the system. The only thing that I added was this using namespace standard, just to avoid putting the commands like std and then get a cout out of it and so on. So in order to avoid all that, I just started using the namespace std. So let's have a nice output for our program right off the bat and say hello and welcome to operators in C++, and then go to the next line, and there you go. So let's run this program right off the bat, and I want you guys to follow along. Don't jump ahead of yourself. It's a good practice to run your program after a change, especially for the beginners who possibly are the audience of this video, and that's going to help you learn better. Anyway, so as you can see, my program without any errors runs, and I have the message going out. So the next step is going to be to define a variable like an integer. Since I'm going to be using assignments and different type of operators in this video, I'm going to need to have a variable to assign stuff to. A good naming standard for the variables is always recommended. However, for the sake of this video and simplicity, I'm just going to name this first variable x, and that's going to be my integer. So what I'm going to do is I'm going to go ahead and start with the first operator, which is the assignment operator. The syntax is very simple. So you have a variable and you use the equal sign and you set up any value that you want for that variable, and of course ended up with a semicolon. While I was writing this, and let me just do this to bring the error up again. So you notice that I had a warning. Let me just get rid of the line. So when you define a variable, you may get a warning that that variable is unassigned or unused. That's just because there is no value inside that variable yet. So as soon as you initialize that value or address it with some kind of value, then you're going to have that warning gone. So pretty simple. Excuse my typo. Pretty simple. It is right over there. Let us go ahead and run this product once more, and you're going to see everything is good, no problem, no errors whatsoever. In order to see what's going on, I'm going to go ahead and print out the value inside x is, and then I'm gonna do this. Oh, sorry, my bad. I'm getting sausage fingers sometimes, so it's gonna be x. And of course, I'm gonna go to next line just to make it look good. And you have it over there. So let's go ahead and run this program once again. And as you can see, it is telling me that the value inside x is 10. So basically pretty simple, pretty straightforward. And I change the value within L, just make it a little bit more readable. So that's all about the assignment operator. So this statement basically assigns the integer value 10 to the variable x, and the assignment operation always takes place from right to left. That's what is important to understand. So it always takes place from right to left. So let's say, just in case, and ignore the errors that are going to pop up, but if I had x equals y, then what is happening is it's not putting the value of x in the y, it's going to put the value of y in the x. So it always go from right to left in order to assign the values. So that's important to remember. Sometimes people make that mistake, and you're going to get to that habit very soon. So remember, it's never from left to right. It's always from right to left, and never other way around. So this statement assigns any type of variable to any type of value that you want to define, and that's pretty much all about that. So now let's go back to that situation of x equal y and see what this does. So this statement assigns to variable x the value contained in variable y. The value of x at the moment this statement is executed is lost, and that's important to understand. Um, Whatever was in x is now lost. So if I have this statement over here and come back here and define integer y equals 6, which is defining and initiating at the same time. And then if I go ahead and now run the program, you should expect the value printed out here to be 6, not the 10, because the initiation of 10 over here is now overwritten by what the value inside y is. And let me just run that pretty quick. And as you can see, now the value inside x is going to be 6, which was the value from y assigned to it. So that's good to be considered. So consider also that we are only assigning the value of y to x at the moment of the assignment operation. Therefore, if y changes at a later moment, it will not affect the new value taken by x. So for example, if I go here and after that assign 3 to y, then the variable y's value 3 is not going to affect the assignment. Let's run it pretty quick. And as you can see, it still remains 6 and doesn't change. So rule 1, it goes from right to left. And rule 2, it executes right at the line and doesn't care about how these values change after the execution. Assignment operations are expressions that can be evaluated. That means that the assignment itself has a value, and for fundamental types, this value is the one assigned in the operation. So, for example, if I have y equals 2 plus, let's say, x equals 5, if I go like that, and for the sake of readability, I really want to put spaces here so you guys can read it. Anyway, if I have that, in this expression, y is assigned to the result of adding 2 and the value of another assignment expression which has itself a value of 5. It is roughly equivalent to say, if I want to put it this way, is I can say y equals 5 and then y equals 2 plus x. So these two together are actually equivalent to what you have over here. And that's one of the characteristics of how you can evaluate everything over there. So basically x, which used to be 6, at this point is going to turn into 5 and then is going to be added to that. So let's do something. Let's get a C out of whatever is the value inside y is this time, and we do the same thing. What I really like to do over here is to add an end line so that we have a better formatting. So let's run this one and see what happens this time. So as you can see, now y is turning to 7 because of this matter. So let me just take these ones out pretty quick so you can only focus on this very same statement. And as you can see, the value definitely is going to be 7. Let's run it. And you see the value of the y is 7. Amazingly, as you can see, the value of x now is 5 because I have an assignment of the x over here. So x equals 5 comes out of all those. So look at it. X has started with no value. Then we set x to 10. Then we set x to y, which was equal to 6 at this point. And then we set y back to 3. Then we said, okay, y is set to 2 plus the value of x, which we are defining 5 right away, right at this point. And as you can see, it gets equal to 5, and x is 5 because the last assignment to x is going to be 5. Now, if I take this guy and print it over here, you should be expecting the value of the x to be different because let's trace it. No value to the x is 10 at this point, then x equals to y, which going back here is 6, and then y goes 3. So you should be expecting for x to show 6. Let's see if that is right. And yes, as you can see, the value inside x is now 6. So again, be careful because in C++ or most of the programming languages, you can change the value of a variable as many times as you like down the road. However, you have to remember, whenever you are reaching there, we don't care about what happens next. So if I put C out over here, I get 6. And you can guess if I just cut this and put it up here, what do you think is going to be the value of x? Yes, you're right. It's going to be 10 because the rest of them are now ignored. So let's clean it up a little bit. Put this guy back down here. So we always have that. And get rid of some of these guys over here. As you notice, this line itself, I'm talking about y equals 3, doesn't have no effect in whatsoever this program is doing because we initiated y at the beginning, which doesn't matter. We set it back to 3, and then immediately we calculated y to something else. So this usually is useless, but I'm using these just for the sake of showing you how these operators actually work. So that's pretty much all I have regarding the assignment operator. And I'm going to clean this up a little bit to get ready to move on to the next operator over here. Okay. So the next operator set actually that I want to talk about are the arithmetic operators. So these operators are, you have plus, which helps you with addition. You have minus, which does the subtraction. You have star, which does the multiplication. And you have slash or forward slash, which does the division. And you have the modulo or percent that does the remainder. So let's get rid of these not to get an error and go through them one by one. So the first one, as you just noticed, we use it over here, x plus whatever. So simple practice is x equals 5 plus 2. And if I go and run this program, oh, excuse me, I chose, and this is a good thing to see. If you say this is a capital X, it doesn't exist. So lowercase x equals 5 plus 2, and now value of x is going to be 7. Very simple, very easy to understand. So the other one, which is even simpler than that, is going to be minus, and you will see the value of x will show as 3. There you go. Next one is the multiplication, and you're going to see the value of x now goes to 10. And you got it over there. And if I divide it And for the sake of this one, I'm gonna go and change this to 6, because if you can guess, I have defined x to be an integer, and if I divide 5 by 2, I'm not gonna have the accuracy over here. So for the sake of just practicing this division, I'll do this. And now you see it is 3. And then as simple as that, I can use the modulus, and you're going to see the value to the modulus is going to be 0 because there is not really a remainder. So I'm going to change this to 5, and you can guess that the value for the x is going to be 1. Remember, in this case we have 5 divided by 2, which is going to be 2. If you consider it an integer, it's going to be 2, so the remainder is going to be 1. So we have 2 times 2 plus 1. Basically, that's how we can talk about 5. 5 equals 2 times 2 plus 1. And this is what we consider the modulus, and that's how you can get it. This is a very useful operator, especially when you're working with feet and inch, or you're working with month, or whatever you want to divide by a specific number and see how many days are remaining and certain how many months are and certain number of days and how many days are remaining, which we are going to discuss later. So operations of addition, subtraction, multiplication, and division correspond literally to their respective mathematical operators. So only on the last one, which is the modulo operator, which is represented by the percentage sign, it gives you the remainder of a division of 2 values. Let's try another one. Let's see if you guys can guess what will be the value of x equals 11% 2. Ready? So your answer was correct, and the result is going to be 1. And the next set of operators that we will go through right now are the compound assignments. So compound assignment operators modify the current value of a variable by performing an operation on it. They're equivalent to assigning the result of an operation to the first operand. Let's look at it. Like if I say y equals plus equals x at this point, what is going to happen is actually the exact same thing that happens if I say y equals y plus x. So take a moment to look at these two. These are absolutely the same. There is no difference if you put this one or that one on the code. So I usually say use it for brevity if you would, but that's your preference. So let's see what's going to happen if we go ahead and run this program right now. So say the value of x is going to be 5, which is the last value that we set to x over here before we come down, and the value of y is 17. So basically what happened was y was 2 plus 5, and you can guess that. Down here, when we said y plus equals x, basically we added 5 to the value of y before that, and then we did that again. So let's get rid of this and see what's the value right now. As you can see, it comes down to 12. So just to make it even easier, I'm going to get rid of these so you guys can actually see it pretty easy. If I initiate x to any value, let's say 2, and then I have y at 6, in this case y is the sum of y and x, so you should be expecting the y to show as 8. So let's see if that happens. As you can see, the value inside y is 8. So if I do the equivalent of this thing, y equals y plus x, you should be expecting to see number 10 for the value, which, as you can see, is right over there. So in the same fashion, I can use minus equal over here, And this time what's going to happen is instead of actually adding the values up, it's going to subtract them. So in this case, you could guess y would be y minus x, which is 6 minus 2. So you should be expecting to see value 4 over here. Let's see if that works. And it works. So we have 4 over here. Again, this one is equal to y equals y minus x. Remember, the order really matters over here. So if I run this, you should be expecting this value to turn down to 2 because another 2 is going to get subtracted. And so it is. So in the same fashion, we can use either multiplication, which is going to be equal to this guy. Now let's run it. Or we actually can use division. While I'm doing division, remember these two values are integer values, so your result is going to be a little bit off. But anyway, that's how it is. And very simple to use, very easy, it's not a big deal. It's just brevity of the expression. And that is all about the compound assignments. So next piece of operators that I want to talk about are increment and decrement operators. Some expressions can be shortened even more. So the increase operator, which, let me get rid of these first. So the increase operator, which actually is this guy, and the decrease operator, which is this guy, increase or reduce by 1 the value stored in a variable. So if I say plus plus x, the thing that it does is it increases the value stored within x. So let me get rid of this so we can let me just clean this up a little bit, make it even better. So when we run this, remember the value of x is 2, and if I run this, the value of x is going to be 3 because it added just 1 to the x. So this basically is equal to x equals x plus 1. Or even more familiar, it's going to be x plus equals 1. So now as you can see, you have 3 different statements that they all have the same meaning. And remember, x is x. It's not the capital X. So x equals x plus 1 or x plus equals 1. So in the early C compilers, the 3 expressions may have produced different executable code depending on which one was used. Nowadays, this type of code optimization is generally performed automatically by the compiler. Thus, the 3 expressions should produce exactly same executable code. So you don't care about how the code is being created. Whichever you like to choose actually is going to end up the same compiled code. So it's only in the older C compilers or C++ compilers that you really care about which one to save some performance, but in this case in C++ 14 that you're focused on, there's no really any difference. So I'm just running this for the sake of fun so you can see x was 2, then added 1 to it, 3, 4, and finally 5. So 3 times adding 1 to 2 is going to turn it into 5. So a particularity of using operators and using different operators is that it can be used both as a prefix and as a suffix. So you can have plus plus x or you can have x plus plus. And if I get rid of these, not to confuse you guys, these two statements can be written. And the question will be, are they the same? And the answer is no. The answer is no. Although in simple expressions like x plus plus or plus plus x, both have exactly the same meaning, in other expressions in which the result of the increment or decrement operation is evaluated, they may have an important difference in their meaning. In the case that the increase operator is used as a prefix, as you see it over here, then the expression evaluates to the final value of the x once it's already increased. On the other hand, in the case that it is used as a suffix, as you see over there, the value is also increased, but the expression evaluates to the value that x had before being increased. So I know it's a little bit confusing, so let's use an example. Let's set x to 3 over here, and I'm going to get rid of these guys. And for the sake of this example, I'm going to say y equals plus plus x. Okay, so let's run this guy. As you can see, x is set to 4 and y is set to 4. So what just happened? Okay, look at this. X was 3. When I did plus plus x, the value of x also changed. So x evaluated to the value after change and therefore showed as 4, right? While y, which is showing the value of x, evaluated to that. So in all the runs, you're going to expect these two to be the same, but look at what happened to x. Now, what I'm going to do is I'm going to change this guy to this, and let's run it again. And as you can see, this time, the value of y is 3, while x is at 4. So the difference is exactly right there. When you put plus plus at the beginning, so when you have this, the value of x, the value of the variable after this prefix actually will be evaluated to the final value, which in this case is 4. So again, as you can see, the value of the entire expression is 4, and x is sitting at 4. But then again, if I go back and implement this, as you can see, the evaluation is 3, while x is increased to 4. So again, although it is simple expression, but they have different final valuations. In the case of the increase operator is used as a prefix, which is plus plus x, of the value, the expression evaluates to the final value of x once it is already increased. On the other hand, in case that it is used as a suffix, or x plus plus, the value is also increased, but the expression evaluates to the value that x had before being increased, which is the value 3 in this case. Although x is increased to 4, but y goes to the value of x before increasing. So basically you can remember it like that. If plus plus is on the right side, y doesn't see that before x. Therefore, it evaluates itself to the previous value of x. While if we put this guy behind, then from y's perspective, that plus plus actually is happening. And therefore, it evaluates itself to the final value of the x. Same story happens with minus minus, and you have to be very careful while using these two. Actually, these two, when we talk about loops and control of the flow, you're going to see they're very useful. Different usage of these, and these two differences are actually helping us to be effectively using them in our programming. Okay, so I think that's enough for the increment and decrement. So the next type of operators that I want to discuss are the relational and the comparison operators. Two expressions can be compared using the relational and equality operators. For example, to know if two values are equal or if one is greater than the other, you can use these operators. The result of such an operation is either true or false. Basically, it's a Boolean value. So what you're looking at is equality, inequality, being greater than, being less than, being greater or equal to, or being less than or equal to. So the entire expression, the entire statement that you're using these operators in there is gonna turn into true or false. So the result is a Boolean value. Let me give you some examples. So the first thing that I'm gonna do is I'm gonna define a Boolean variable named z. And just in the output, I'm gonna add another line. Let's call them the control lines as we are using them as control. The value for z, which is going to be the truthfulness, is, and then I'm going to go ahead and add z, and for the sake of being nice and neat, add a line to the end of it. So if I say z equals to 7 compared to 6, for example, you can guess that 7 is not equal to 6, therefore the value is false, and therefore whatever is going to be inside z should be 0. So let me run it again, and you see it is set to 0. If this guy be 6, it is true, and as you can see, it is set to 1. So Boolean value, very simple to understand. So now, instead of this and that, I can simply just use x and y to compare them. And at this situation, you can guess the result is going to be 0 because 3 is not equal to 6. But if I change y, let's say if I set y, just for the sake of doing this, if I set y to same value in x before I run this, you're going to see over here that now the value for z is 1 because it is true. Very simple to be used, and you can draw over there. You can just try anything like this. You just name it and practice at home to see how these things work. If I get rid of this one, let's see what is going to happen. So x is not greater than or equal to y, so I'm expecting the value for z to turn into 0, which is the case. And if I do it in another way, now I'm expecting it to be 1. And if that is 1, I can actually put a not at the beginning of it, and now I'm expecting the value to be 0, which is the toggled value over there. So this type of operators, the relational and comparison operators, are usually used in creation of the loops and again moving control around. Once more, let's see what do we have in here just to refresh your memory before you go. Equal, which I want you to notice that this assignment is different from this guy. So this is the comparison operator, that is the assignment operator. That's again another pitfalls that I have seen a lot of time. New programmers fall for it. So you have greater than or equal, you have less than or equal, and you have not equal, which actually is what I actually used over here right now in this case. And then you have the simpler one, which is greater than or less than. So that being done, now let's talk about the logical operators. So basically logical operators are not operator, then we have the and operator, and then we have the or operator. So just out of my OCD, have them all at the same line, and now you have not, and, an or. So let's see how they work. There is a truth table for logical operators, which I have it in one of my slides over here. As you can see, when you're talking about the OR operator, in order for the result of the OR operator to be false, and just look at this one, you need both of the operands to be false. In any other situation, the result of OR operator is going to be true. and it is in reverse for AND operator. So in order for the result of the AND operator to be true, you need both operands to be true. Any other situation is going to create false. So basically, if just one of the operators is false, the result of the AND is going to be false. While if one of the operators is true, the result of the OR is going to be true. And of course, in case of not, it's going to be negate of the result. Going back to the code, let's do this. I already have initialized z to 1, which is the true. And if I define another Boolean operator and call the Boolean operator, let's say h, and set it to 0, just to have an initial value. And here, if I say h equals, let's say, not z, you can guess that the result that I'm going to get over here is going to be 0. So, as you can, we need to have z printed out. Let me just pretty quick cheat and add another line for the value h. Basically, I'm just using information of the value z to create this line, and let's run it again. And you see the value for h is 0. Now let me initialize it to 1 so you guys can see the change. Now you see h is 0. So it was initialized to 1. Then we said h is equal to not z, negate of the z. And then that's going to be 0. Also, we can try this way. If we have a comparison to do is, let's say we say h equals, if 3 equals 3, which you know the result is true, and 5 equals 5. So obviously the result of the h is going to be through, because I have through over here and through over here, so h is going to be set to through. But if just one of these guys goes wrong, if I have 4 equals 5 over here and run it, you're going to see now h is going to be 0. Because this one is false, it doesn't care what this one is. If this one is false too, still I'm going to get a false. So in order to get a true, I need both of these guys to be true. So let's do another thing. Let's do an AND. So if I do an let's do an OR. If I do an OR and go here, the result is still going to be 0 because both are false. But if I turn this to something that is actually true, you're going to see the final result is going to be 1 or true. So again, let's go back here again. When I have the AND operator going between two operands, if one of them is false, the result is going to be false. You see this? Both false, false. This one false, result is false. This one false, result is false. So I need both to be true to get a true. And over here, for the OR, I need only one to be true in order to get true out. And it's only false is if both of the results are actually false. Remember that when using logical operators, C++ only evaluates what is necessary from left to right to come up with a combined rational result. So if you are the person to run the code and you know with just one false you're going to have the entire statement false, you most possibly are not going to continue calculations when you see a false. And this is exactly what C++ does. So for example, let's do this. Let's say if 5 equals 5 and I want to say, I don't know, 3 is greater than 6. Actually is good. So what happens is this one is going to get evaluated to false because you have true and you have false. Basically, when true is being seen, we're not going to move to false. But if this one was 6 compared to 5 and 3 greater than 6, compiler would have stopped right here, because when you have a false and you see and, no matter what is coming hereafter, the result is going to be evaluated to false. Therefore, there is no reason to waste time and calculate the rest. This may not sound very important right now, but guess what? If you had some kind of calculation in here, like if you had x plus 2, and then you were comparing this with another, I don't know, y plus plus greater than 6, or any type of statement like that. And yeah, syntax, don't care about syntax. Let me just do this so it gets away. But anyway, if you have that, then x will never be 2. We're never gonna get here. So x is gonna remain 3. So if I run this program, you notice that x equals 3. X never changed. It never changed to 2. But if this one be true, and I'm going to run again, and you're going to notice that x is going to change. See, now x is turned to 2. So basically, again, I'm repeating myself. Compiler starts from the beginning point from the left and calculates and moves on. If enough information to evaluate the entire statement is available to the compiler, at that point, compiler is going to cease calculating and computing the rest. So that's why you notice if this is true, compiler needs to know what is the other hand, so it moves and sets x to 2. But if this one is false, again, like if this is like that, compiler is not going to move on and set x to 2. Therefore, x is going to stay 3. And you see now it's 2. I'm going to run it again. And x is going to be 3, never getting to 2. So every time you use compound statements in comprehension and in calculation of the logical operands and operators, make sure you don't miss logical errors like that. And remember, we were talking about the possibilities of having logical errors in your program. This is a good example of a logical error that you may face. Okay, now that I scared you enough, I'm going to clean up my board. And okay, let's start talking about conditional ternary operator, or this guy. So the question mark, or the conditional ternary operator, basically evaluates an expression and returns one value if that expression evaluates to true, and a different one if that expression evaluates to false. For example, if I have my condition here, let me just put it down. Like if I have my condition here, and then I put the question mark, then I can have two results. So basically, I can have result 1, and I can have result 2. So if the statement, if the condition that I'm working with turns to be true, result 1 is going to be done. If it doesn't turn to be true and it's false, result 2 is going to be done. Okay, I'm going to keep this line over here. This is not the code, it's just for textual part. But let me just turn it into a comment, so it's going to get away. And let's look at this. Like I say, what if 7 equals to 5? If that is the case, then evaluate to 4, and if it is not the case, evaluate to 3. So basically, that's how you do this thing. You have the condition, then you put the question mark, and then you decide what is going to be the evaluation after truthfulness or being false. Like in our example, so if I can say, let's define like integer x. I'm going to add another integer for the sake of this and call it integer a with no initial value, and let me adjust this a little bit so we still have enough room to go on here. So I'll say a equals, and now I want to decide the condition. I'll put any type of condition, you just name it. If x is greater than y, since we do have both of them, and I'm going to ask the compiler to check it. And if x is greater than y, then a is going to be 10. If it is not the case, a is going to be 100. So as you can see, it's very simple. I have my value in the reference space and everything. If x is greater than y, be true, then I'm going to set a to 10. And if it is not true, I'm going to set a to 100. Let's play with it. As of now, x is what? X is less than y. Therefore, this is going to turn to false. And then the value for a is going to be 100. So let's do a quick cheat over here, because we want to add a to our game. There you go. That's good to go. So let's run this. So did I miss the value of a? Oh yeah, the error over here, I forgot to say out. Okay, now it is good. Run it again. And as you can see, the value of a is set to 100 because this condition is true. Now what I can do is I can go ahead and change x to 9. So this condition changes now, and you're expecting the value to be 10. Excuse my wrong explanation. Right now, before when it was 3, this was false, and therefore we switched to 100. Now it's true, and we have to switch to 10. So let's see. There we go. And as you can see, the value inside A is 10 right now. So this is a very advanced way of coding. The code is very simple and nimble over here. And it actually helps you get rid of all those if, then, else statements, because this is equal to if x is greater than y, then a equals 10, else a equals 100. So this is more brief and helps you in the brevity of your code. So the next operator to consider is the comma operator. For this point in our class or in our lecture, it is a little bit tricky because we haven't talked about casting yet. So when I'm doing this, you may see some warnings, but ignore them for now. The comma operator is used to separate two or more expressions that are included where only one expression is expected. When the set of expressions has to be evaluated for value, only the rightmost expression is considered. For example, if I say a equals, let's reinitialize x to 3, and then x plus 2 for say, if I use this expression, then what happens is the code would first assign the value 3 to x, and then assign x plus 2 to variable a. So at the end, variable a would contain the value of 5, while variable x would contain the value of 3. So let's do this. Let's run this and see the result. As you can see, x has the 3, which we assigned it to it right here. Okay, and a has x plus 2, which is equal to 5. So as I predicted, we have a warning about the misuse of the operator. We can cast this to void and get rid of this, but for the beginners, I don't want you to get involved with the casting right now. Just forget about it, and you can learn about this later down the road. For now, you can easily use that without any compiler error or any type of logical or semantic error, so don't worry about that. That's pretty much about it. So remember that we have commas in those parentheses, and it's going to calculate from left to right, and the value of x is not going to change when you say x plus 2, which basically is a equals x plus 2. Good, so now let me get rid of that. So the next operators that I want to talk about are the bitwise operators. So bitwise operators modify variables considering the bit patterns that represent the values that they store. So there is an operator called AND. There is another operator called OR. Then we have the XOR, which is this. Then we have the NOT, which is this. And then we have shift left, which is this. And then we have shift right, which is this guy. So remember that when we put shift left and shift right, these are different from what you remember as the insertion or extraction operators earlier on in this class. It basically is used for bit manipulation, and we don't have that much of use for that unless we go lower in the levels. The next set of operators are going to be explicit typecasting operators. So basically, typecasting operators allow to convert a value of a given type to another type, which sometimes is useful when you want to move between integer or a float or something like that. There are several ways to do this in C++. The simplest one, which has been inherited from the C language, is to precede the expression to be converted by the new type enclosed between parentheses. So let's get rid of the bitwise operators and go over there. So I'm gonna start from the scratch. Let's say I have integer I that I initialize over here. So that's the integer I, and I have a float which is float f, and I'm going to initialize it to 3.14 pi number. So if I say I equals integer and then put f here, I have basically casted the float number f to an integer. Okay, and if I put this in x, just right here, to help even more, let's get rid of I. So we already have the output over that. So we have integer x equals whatever float f is that. And if I run this program, you guys are going to see that x shows the integer part of the f, which is 3. So basically, it cut over the part of the f that was out. So this code converts the floating point number 3.14 to an integer value, which is 3. The remainder is lost. That's important to remember. Here the typecasting operator was integer within the parentheses, so this is the typecasting operator in this case. But there is another way to do the same thing in C++, and that's to use the functional notion preceding for this type of expressions to be converted by the type and enclosing the expression between parentheses. So basically what I'm talking about is I can say y equals integer f. So whichever of these two forms you look at, they're going to have the same result, and they both are approved and accepted in C++. If we run this, you're going to see the value of x and y both is going to be evaluated to 3. And that's pretty much it. You can cast a float to an integer to a float, a boolean to an integer to boolean, and all the things. So you can just name it and you can cast it over. However, you have to know what actually happens in this casting. Like in this case, when you cast from a float to an integer, you're losing the remainder part, and you actually are there with the number 3, which is the integer part. That sometimes could be helpful in the algorithms you design, and sometimes could create logical errors for you if you don't carefully take advantage of this ability of the C++. Okay, now let's get rid of these guys and talk about this size of. The size of operator basically accepts one parameter, which can be either a type or a variable, and returns the size in bytes of that type or object. So if I say x equals size of a character, right? What happens is x is assigned the value 1 because character is a type with a size of 1 byte. Then the value returned by size of is a compile time constant. So it is always determined before program actually executes. So let's run this, and you can see now the value x is showing 1 because the character type has the size of actually 1 byte. So I'm going to go in and change it to integer and run it again for you. And you're going to see in this case the character size, the integer size is going to be 4 bytes, as we discussed in other videos beforehand. So if you remember from the constants and variables and explanations that we had over there, the size of integer was 4 bytes. And you can do the same thing for any type of information, any type of variables that you have. Let's go with booleans and see what is the size of bool. And you can see now variable x is going to cast to 1 byte. It doesn't need more than 1 byte. It's only zeros and ones. And for the last try, let's do float. And if we run float, you can guess the size is going to be 4. There we go. So that's pretty much about the size of. So later down the road, we're going to discuss other type of operators, a few more detailed operators like the ones that referring to the pointers or the specific for object-oriented programming operators and all that. But as of now, that's all that we want to talk about in this video about. These are all the operators that you needed to go through. As you noticed, it's very simple to work with every single one of those. So now that we understood and reviewed some of the operators, most of the operators in C++, we have to understand and be aware of the precedence of operators. So basically, a single expression may have multiple operators. Let me just put something down here, like x equals, I don't know, 5 plus 7 mod 2. So take a moment and think about what will be the value of x at the end of this expression. So in C++, this expression always assigns 6 to variable x because the remainder operator, the modulus operator, has a higher precedence than the plus operator and is always being calculated prior to the plus operator. So parts of the expression can be enclosed in parentheses to override this type of precedence order. So if you don't like how C++ has its precedences, then you can do it your way. I'm going to show you right now what I'm talking about. So if I run this program, the x is going to be set to 6. But if I come back here and ask the compiler to compile this first, then you're going to see the value of x is now set to 0. So as you can see, parentheses are going to get higher precedence, and it's going to create 12. 5 plus 7 is 12. And when you divide 12 by 2, there is no remainder, and therefore it shows 0. Well, if I get rid of that, again, you will see the remainder value is going to be 6 because this has priority over plus. So let me just pull up the slide pretty quick so you guys can actually look at this table. This is like the Bible for the operator's precedence. Take a look at it. You need to come back here every now and then and remember what has a higher priority to the other one. As you can see, the scope qualifier has the highest priority. Remember when we were running the command std : say in, say out, that actually has the highest priority when it comes to it. Increment and decrement come next. Functional forms, subscript, member access, prefix increment, decrement, bitwise not, logical not, and so on and so on. So going down the list, you're going to see the sequencing has the lowest priority and it's going to be calculated at last. Assignment level expressions themselves are coming really low. And as you can see, you go up to the logical ones, and then you go up to the shift one, bitwise ones, and go up multiplications, access pointers, and so on. And remember, grouping for some of them is left to right. So it starts from left to calculate. For some, like the assignment level is right to left, which makes sense when you want to assign some value to a variable. And then again, postfix ones have the left to right priority. So that being said, we're done with our video about the C++ operators, and thank you for watching.